All right, so to wrap up Unit 3.1, the conversation is symmetry, and we talked about reflecting things over the x-axis and y-axis, but what we actually are going to look at here is what does symmetry with respect to the x-axis look like? What does symmetry with respect to the y-axis look like? And what does symmetry with respect to the origin look like? So what I would think would be the best for you to do at this point would be to draw a rough sketch of those three graphs and say to yourself, this is what symmetry about the x-axis, symmetry with respect to the y-axis, and symmetry with respect to the origin. This is what it looks like essentially. Obviously, there's different variations depending on the function itself or what we're looking at. For more advanced situations, you do want to take into consideration the effect of the ordered pair, but my next screen will hopefully help you understand this relationship of the ordered pair, that if you reflect something over the x-axis, why does your y value change? If you reflect something over the y-axis, why does your x value change? And if you reflect something over the origin, why do both values change? So we'll touch on that in the next video, the next slide. Okay, so hit pause, get the rest of that copy down, then come back and we'll look at the next slide. So a way to help you understand like why those variables change is we can just take an ordered pair. But let's first establish and review the quadrants. So we have 4 quadrants inside of a coordinate plane. Let me do this a little bit bigger so it's kind of easier to write on. Okay, so we have 4 quadrants in a coordinate plane, and in those quadrants, this would be quadrant number 1, quadrant number 2, quadrant number 3, we use Roman numerals, and quadrant number 4. Okay, remember when you plot on the x-axis, these are going to be positive x's. This will be negative x's. These will be positive y's, and these will be negative y's. So in this quadrant right here, you're looking at ordered pairs that are going to be positive x's and positive y's. When we come over to quadrant 2, will be negative x's and positive y's. We come down to quadrant 3, this would be negative x's and negative y's. And quadrant 4 would be positive x's and negative y's. So we start off with our ordered pair, which was negative 3. So we start at the origin, we go over 1, 2, 3, we go up positive 1, 2, 3, 4. So that ordered pair right there would be negative 3, 4. So the first one would be is that if we reflect it over the x-axis. So according to our rules for reflection over the x-axis, we would have our original ordered pair, and it would be the y value that would change. So let's see if that makes sense. So when we flip over the x-axis, that means that we find our symmetry. This is 1, 2, 3, 4 units above the x-axis. So I'll be 1, 2, 3, 4 units below the x-axis. And you can see that that ordered pair right there would be still the x value didn't change, but the y value did. So this guy would be negative 3, negative 4. I don't know why I changed colors there. Yeah, that makes sense. I'm sorry. Okay. Well, let's see. Does yellow show up? Let's do the y-axis. So on the y-axis, we're going to take the negative 3, 4, and we'll reflect it over the y-axis. So according to our rules, over the y-axis, it's the x that will change. So we are 1, 2, 3 units away from the y-axis. So we go 1, 2, 3 units further over. That's our new ordered pair. That ordered pair is 3, 4. So you can see that the y value stayed the same, but it was the x that changed. Last but not least, we have a reflection over the origin. Write that ordered pair down. That was 3, 4. Last but not least, we have the reflection over the origin. So over the origin, we have both values change. And the origin is actually a reflection over both. So it's like when you do the origin, you do a reflection over the x, and then you do a reflection over the y. So we've already done it. So basically, you reflect over the x, and then you take that guy and you reflect it over the y, and you come out with your new point. In this case here, it would be 3, -4. All right, so remember in this case, it was both the x and the y changed. So you can see the -3 turned to +3, the +4 turned to -4. So reflections over the x-axis, y-axis, and origin, and being able to identify them just comes into play a little bit later in your coursework.